Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 134, number of subarrays with and values of k. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I think this one has the potential to be a very hard problem, but now it is just mildly hard. And I don't mean it as a, like if you have struggled with this one, this is still a hard problem. But the thing is that, just to kind of give you my perspective and my point of view, the thing about this problem is that there was a very similar problem about 2 months ago on Leetcode, maybe something like this, I don't know. And that's the thing, right, is that people learn and you should learn. And once you actually understand the concepts, it gets easier. And I was able to solve this in about 8 minutes. I have two wrong answers, to be honest. One of them is a silly UI issue. So I have the old UI here, as you see. And the reason why, and I got a one-time error because in the new UI, apparently like there's a shortcut for submitting code, like a keyboard shortcut, and I hit it. I don't know what it was, but I hit it anyway. And then I just got a wrong answer because, also just to be honest, I really needed to use the restroom, and I kind of just rushed it because I had a placeholder for an answer that I was like, all right, Larry, remember to check, but then I just forgot to check it and I submitted and I got a wrong answer. So very silly mistakes, very unfortunate. But okay, so this one it's gonna be dynamic programming. This is a 7-point problem, keeping in mind. So I'm not gonna go over the details about dynamic programming. Because you should have a good fundamental understanding of dynamic programming before attempting this problem. If not, I'm not trying to be mean, but there's a lot of foundational things you can do, right? The things that are with learning with dynamic programming. The thing about dynamic programming that is hard for a lot of people is that there are a lot of different types of dynamic programming, so you cannot just get by memorization. I mean, maybe you can because that's how I didn't memorize this one, but I did remember some ideas about this one, right? And then the second thing is that, and I say this a lot in a lot of my videos, understanding the solution is not the same as being able to solve the problem and understanding how to solve the problem, right? I think this is one of the complaints that I have a lot about my videos is that people don't understand it, but sometimes. And honestly, it is not my 100% goal to get you to understand the solution, right? My goal is to get you to understand how I, Larry, well, maybe not this contest, a top-ranked competitor, thought about and approached this problem. And sometimes how I approach it and how I attack this problem will, with that journey, you may understand the solution itself, all right? Look, there are thousands of videos out there, maybe not thousands. There are enough videos out there of people just explaining the solutions. You don't need this video. The reason why I do these videos is so that you can understand how a top competitor thinks about a problem, and also how to arrive at that problem, including all the annoying things and stuff, right? As I said again, understanding the solution. If you're sitting on your couch, not really doing anything, just like watching this like it's TV, and someone explains to you in a way that you understand it, sure. But you're not here because you want to understand reading solutions or someone explaining solutions to you. You're not here because you're trying to get better at watching YouTube videos to understand solutions. Maybe you are, I don't know. But my goal is so that you can understand how to get to that solution, not to understand the solution. There's a distinction there, and I hope you understand it, and I hope you appreciate it. Right? Okay. And this is why I kind of talked about the thing with understanding the problem from a couple of months ago. I don't remember the problem, but probably I'll leave a comment. Someone will probably comment on the Discord when the contest actually comes out. But yeah. So okay. So I think for this one, like I said, you have to have a strong understanding of dynamic programming and not just understanding of being able to implement, of course. And then maybe it makes sense. The idea here is, just going to be I think I'm going to go over it by showing you the code because, we already said that it's dynamic programming, and I assume that you understand the problem. It's a very short statement. It's a bitwise AND of subarray elements, right? And and this is the way that I did it. And okay, so basically, I go, okay, if we start at index I, what is the how many subarrays starts at index I, right? Maybe that's another better way of phrasing it. That ends with the bitwise n equals to k, right? And then the dynamic programming, if you have a background in dynamic programming, like I said, it's actually not hard per se, but it's going to be and this is basically what this is saying, right? So how many subarrays starts with current index and the current bitwise n of the previous arrays, previous indexes, equal to v, right? Yeah, whatever. Okay. I mean, I think this, in a way, this is brute force, right? In a way, this is brute force because basically you just now break out all the cases. If v is less than k, I return 0 because it's no longer possible. I think technically you don't need this, but it's fine. If v is equal to 0, we have a special case. I have a special case, but to be honest, I think these cost me, like these are optimizations that you don't actually need. And I think, I think honestly, it cost me a wrong answer because I didn't need to think about this. Let me double check to see where I'm lying to you. Let's give it a submit. I don't think I need those. Maybe it makes some, so I think I just made it a little bit more complicated and gave myself a wrong answer actually. But but basically, if we're at the last element, if the v is equal to k, we return 1, otherwise we return 0. Here we have total is equal to 0. If v is already equal to k, then what does this mean? We can end the subarray here for a contribution of 1, right? And then here we just keep going, right? We can keep going. So you can almost think about it in a traditional way, even though the loops are a little bit weird. You can think about this as tick, no tick, right? No tick, stops. Oops. Yeah, and now that I kind of write it this way, I kind of feel silly for having those extra if statements because they cost me wrong answer. Because I had a base case a little bit wrong. And the reason why I did that is just for, honestly, premature optimization. I optimized for time, but the time was a little bit funky as a result. But I didn't need to, right? So, and you don't, But that's basically the idea, tick, no tick. So what is the hard part about this? I mean, this looks pretty straightforward. By itself, this would probably be, I don't know, like a easier difficult for dynamic programming. The hard part is if you're like I said, if you're practicing dynamic programming, then this could be, then you look at the constraints and you think, how does this work? Index to go from 0 to n. V has 10 to the 9, but let's just round up and say it has 32 bits. So it's going to be 2 to the 32, right? And of course, if you kind of take this like this, then of course it doesn't, it's not going to be fast enough because, well, n times 2 to the 32 for every possible n, it's going to be too big, right? This only takes 2 operations, but it's still going to be O of n times 2 to the b, where b is the number of bits. This is too big. 3 exclamation point. So the reason why this is fast enough, though, is that we have to think about how this read function changes over time, right? And as I said, the reason why I was able to get this very quickly is because there was a similar problem. Maybe it was bitwise or, but still a similar idea, right? And I'm taking up the drawing things right now. Is that okay? So let's say we have read, right? And the way that I would think about it is that it's a number, right, from 1 to the 2 to the 32 minus 1 or whatever. So, but the way that I'm going to draw it is vertically. So basically, for example, maybe we have 10, right? So read is equal to 10 here. So what is 10? 10 is maybe a more a number, right? So let's say let's just actually say is just 5 ones, which is 15, right? I think maybe, I don't know, hopefully. So this is equal to 15, right? 1, 2, 4, 8, 16. Okay, fine. I was wrong. This is 32, right? 31, right? The thing is that for every bit, there are only 2. So let's look at each bit, and that's why I draw them vertically, is look at each bit independently as we go through more and more values. Well, what happens? Well, this 1 can only go from 1 to either 1 or 0, right? And obviously dot, right? But because this is bitwise and the thing is that once it goes to 0, okay, so 1, it can still goes to 1 and 0, but the 0 will just go on 0 forever, right? All the way through. So that means that if you kind of think about if you think about how this change is made, that means that there's going to only be one point in which this goes from 1 to 0, right? And the same thing for the next bit, next bit, next bit, next bit, right? That means that for 32 bits, there are only 32 changes, right? Because it doesn't up to 32 changes, because sometimes in some rows you can, or some columns, you can change more than one number, right? So that means that, for example, if you have 31, let's say we flip this bit to 0, the first bit to 0, right? That means that, we can have, let me change the color real quick. Let's say we have 0, 1, 1, 1, 1 now, right? That means that no matter what, the first number is going to be always 0, and then so forth. So then now, basically, if you look at it this way, then, and the thing is that once there's no choice, right? Because these are all numbers that you have to do because there's subarray. So then this is re sub 1, say, this is re sub 2, re sub 3, re sub 4, right? So that means that it always happens here, right? And that means that there can only happen in, that's not a 0, but, let's say the next one goes to 0, 0 here, right? That means that it always happens in the same places. And that means that, it always goes the same way, right? Because there are only 32 possible bits, or 31 or whatever. So now, and you can think about it in either way, going forward or backwards, is that in a subarray, as you extend, the number will only go smaller. So, yeah. But yeah, so actually, we can only, for each index, we can only take on 32 or 31 or whatever unique values, right? Because now thinking back, this is the input from a previous starting array. And so from a previous starting array, there are only 32 places where it can change to go from 1 to 0 coming in. And as a result, this is just going to be O of n times 32, which is fast enough, apparently. Actually kind of tight, but yeah, fast enough for this one. And that's basically the hard part about this. Yeah, the hard part about this is kind of thinking about it in this way, and just doing it in a kind of brute force but not really kind of way. And yeah, and as I said, the reason why I kind of just to go back a little bit, the reason why I was able to do this so quickly is, and some of it was that I had some off by one issues, so that's why I was debugging a little bit. One of the wrong answers, like I said, was because there was a shortcut thing on my keyboard, and I don't know. Someone tells me that it's Control Enter, so I probably had Control and then press Enter by accident, and it's automatically submitted on new UI. Thanks, Leetcode. And yeah, and then the second one was because my base case was wrong. I could show you in a second. I had an additional base case, so this should be I'm not gonna lie, during the contest I really needed to use the restroom, and I mentioned this a few times during the live video. But yeah, when I wrote this, I thought that 0 would be a special case because it goes on forever. So we wanted to terminate early, and the number of counts is going to be either n minus index or n minus index plus 1. I told myself to check for this, and then but because I needed to use the bathroom, I just kind of rushed in. I just so I just got it wrong. But it also that's why I was able to kind of submit very quickly after this, right? Because I knew that this was wrong. I submitted right afterwards and fixed it. The right answer had n minus index plus 1, because I just knew that it was either one or the other. But I just forgot to take account of it. But like I said, you don't even need it. It's just, I don't know, silly mistakes of Larry just waking up and needing to use the restroom and just not thinking 100%. But yeah, that's all I have for this one. Let me know what you think. Like I said, the reason why I was able to do this very quickly is because there was a similar idea in a previous problem, so it just made this a lot more straightforward. And I think A-Rice actually, I wouldn't say directly that he taught me this idea, but still a lot of credit to A-Rice, because the last time we did this problem, like 2 months ago or whatever it was, he did it this other way, and then we just like, oh, why don't you just do it this way? I'm like, oh. And then it took me like, a couple of minutes of thinking to figure out why it worked. And so like, and as the same and he also did very well. I think he did it in a virtual contest though that time, and he did it very well. But yeah, that's why, one is congrats to A-Rice, but also to Alex. Not surprising to see it finish in 2 minutes as a result. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. This is so annoying to kind of look. This new UI is horrendous. It is. I don't know. Talk about it later. Given an array of integer nums and an integer k, return a number of subarrays of nums where the bitwise n of the element of the subarray returns k. Focus on. Okay. Bitwise n of the element of the subarray equals k. Okay. Did we do this one? 632. Yeah, that's wrong. That's right though. Why do I have 5? Why is this 5? Zero is 3. Right? 1. Because this is 2. This is not 2. Is this should be 1. Why am I? This is 2. Oh, I see. Did I submit? I can't even. Maybe I submitted. I don't know. It's unclear. Okay. But now I have 6 for this. And 1 for this. Okay. Man, I really need to use the restroom too. Okay, this is 2. Oh, this is wrong. 6, 3, 2. Okay, let's get rid of this UI is so whatever. Okay, fine. 632 YOLO submit. I thought I had it, to be honest. Oh, K is 0 to 0. What does K is 0 to 0 mean? Oh, I actually did have a case for it. I meant to test this one too, but because that's why I have a case there, but then I just didn't think about it. Cases expected 11, I got 6. Oh yeah, maybe it's this thing. Yeah, okay. I think it's because I was tilted on needing to. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.